Alright, so this is for 2012 PAT, Unit B, Chemistry 1, numbers 11 onwards. So in this one, the melting of ice, the second you see that, it's just melting. You can change that back from liquid to solid and then even to gas and back. That one is a physical change because the process is reversible. Okay, when you produce a new substance, then that's your chemical change. So the correct answer here is D. 12 is not something we often learn very carefully, but if you look at H for hydrogen and O for oxygen, those are each one atom. Okay, so one atom of water, no, it's got three stuck together here. 3 atoms of water, no, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the first two, nope. 1 molecule of water, that would just be this bubble, but instead we have 3 molecules of water, 1, 2, 3. So, what was that, D? Okay, trying to scroll down, being denied. I would like question 13, please. Too small. So here we have with our naming, and Chris apparently is naming chemical formulas and writing their appropriate names. So let's see which one did he get right. Let's look at each of them one at a time because that helps us understand what's going on. S, sulfur, O, oxygen. Those two, according to our periodic table, are nonmetals. So it should be disulfur monoxide. Is that what was written? Nope. Then we have calcium and sulfur. Calcium here, sulfur here, so we have a metal and a nonmetal. That's ionic. So we should be using our other naming system with no prefixes. And then Ca is calcium, not carbon. Okay, so that's a big clue right there. Here we have nitrogen and oxygen. Nitrogen, oxygen, both nonmetals, so it should be nitrogen monoxide. Okay, so that's the right one, number 3. And magnesium dichloride. Let's take a look. Magnesium here, chlorine here. So we have a metal and a nonmetal, so that's ionic. So that means we don't use the prefixes. So we should not have mono, di, tri, tetra, penta, all those things on there. Okay, so we don't want the magnesium dichloride. It would just be magnesium chloride in that example. This one has us starting with hydrochloric acid and reacts to form the products of hydrogen gas and chlorine gas. So what's going on in this reaction? Combining hydrogen gas and chlorine gas produces hydrochloric acid. That would be right if it was the other way around, right? If these were the products, or these were the reactants and that was the product, but it's not. Okay, this is a decomposition reaction. So combining hydrochloric acid with hydrogen gas, that means you'd have HCl plus H2 produces, the little arrow, produces chlorine gas. That's not what it says. Hydrogen gas is produced when hydrochloric acid is combined with chlorine gas. So this one would be HCl plus Cl2, reacts to form hydrogen, but it doesn't. So it's probably the last one here. So hydrogen gas and chlorine gas are produced when hydrochloric acid is broken down. Yeah, that one. Okay, looking at our periodic table, we have the alkali earth metals family group, same thing. Noble gases, but they're not listed here. We just have nonmetals on the right-hand side of the staircase. We have transition metals in the middle here, and some alkali earth metals and metalloids. And then 2, I'm not sure what they're showing exactly. It might be the lanthanides and actinides, but that should be separate. So let's find out. Identify the row that correctly describes the patterns in the periodic table. Okay, so in row A, that means I is an example of a family. Yes. Okay, so it's got to be A or B. 2 is a period. Yeah, okay. So this is like a row. So the period 6 or period 5, that would be the whole row. Okay, so we know it's either A or B still because those are the same. Group 3, metals, yep. Group 4, nonmetals, yep. So 15, row B. Dissolving sugar in a beaker of water. Okay, so sugar is carbon, hydrogen, and oxygen. Hopefully you remember that from one of your worksheets. So individually, water by itself would be a compound made of 2 elements, hydrogen and oxygen. And sugar is a compound, which can't be broken down further. It's funny, I just shook my head even though it's a video. And these are classified first as compounds, and you mix them both together, and it's a solution. So you're assuming, in this example, that all the sugar is dissolved. Okay, and then there's none left. So we'd have a solution. So they are both compounds, made of elements, compounds, that form a solution. Fluorine. It's asking how many electrons and how many neutrons we have. So how many protons and electrons we have is the atomic number. So 9. Fluorine has 9 electrons. Okay, so which one says 9? This. The atomic mass, which we usually write on the bottom, but that's okay. The atomic mass is 19. So to figure out neutrons, we go atomic mass minus atomic number, and that's how many neutrons we have. So 19 minus 9 is 10. So we have row A is the correct answer here. So 9 electrons, 10 neutrons. These two reactions, combustion and corrosion, they're hoping that you learned that. So combustion is where you take some kind of fuel source like methane and oxygen, and you react that to produce carbon dioxide, water vapor, and energy. Okay, heat and light. So that's our combustion, burning anything. And corrosion, which is rusting. So you take some iron, or oxidation is another word for it, and oxygen and water. You react those together to make iron oxide and water. So you took water, you have water left over. Okay, so what ends up happening here? Combustion and corrosion are similar because they both burn oxygen. Let's see if that's on the list. Require oxygen as a reactant. Yes. Okay, the reactants are on the left-hand side. The products are on the right-hand side. Has a metal as a reactant? No, because the fuel source is not necessarily metal. Release oxygen? Nope, that's photosynthesis. Release carbon dioxide as a product? No, that's cellular respiration, which is what people do, which is the opposite of photosynthesis. Okay, next one. So we put magnesium metal in hydrochloric acid, and we produce hydrogen gas bubbles, which we can capture with a balloon and light on fire, and it's very exciting. Okay, so which ones are going to react the fastest? Powders are going to react faster than a metal strip, so it's going to be this one or this one. And stirring or heating it up would also make it react faster. But the other thing you want is a more concentrated acid. So 5% hydrochloric acid per volume, not as strong as 10%. So we're going to go with this one here. So stronger acid, metal powder, bigger boom. Okay, so they put in fluorescent dye, hydrogen peroxide, and some kind of chemical. And it produced heat, and it glowed green. That sounds exciting. So what type of reaction did the teacher demonstrate? Well, if it produces heat, okay, that means it's an exothermic reaction, releases heat. Endothermic would be it getting cold, like cold packs. Combustion is burning. Okay, so it could technically be burning, but it doesn't say anything about mixing with oxygen or producing any kind of waste products. Okay, it just says heat and a bright green glow, so it just says energy. Same with corrosion, we just talked about that one. Okay, that's more about rusting. What are these ones? Oh, okay, ionic and molecular. So back to our periodic table. These guys conduct electricity and heat. These ones don't. So if they are molecular, that means it's a compound made of nonmetals. If it's ionic, it has nonmetals and metals together. So let's check it out here. Okay, is it ionic or molecular using the following code? If it's a gas at room temperature and doesn't conduct electricity, it's probably nonmetal. Okay, so that's going to be molecular. So we would put a 2 in the X box. Xbox, like the video game. Why? Yes, it conducts electricity, and it's solid at room temperature, so it's probably ionic, because a metal and a nonmetal might conduct electricity. Okay, so let's put 1 here, ionic. Substance C conducts electricity. No, it doesn't. And it's liquid at room temperature. That's not the best question in the planet. But let's go with molecular. Okay, and whenever we're not sure, we can always scroll up to the answer key. So let's look at the last one for Z and see what the people who made up the test thought the answer was. Okay, was that numerical response 2? 2, 1, 2. Okay, so they figured that was molecular, which is what we decided. Okay, so that's it for those questions. Rewind, push pause, whatever you need to do.